Okay, so we have enough background of logs to start to talk about the real purpose of these things are. Why do we use them? What are they used for? Today gets into we're going to use the calculator and do some things outside of context, and then the next section we're going to actually solve some real world type problems. Okay, um, but the whole idea about logs is to be able to solve for an exponent, and an exponent that you normally wouldn't be able to solve for. So, for example, something simple: 2 to what power equals 5? Right? Something that we don't know. If we have an idea, we can approximate that. That's going to be between what and what? Between 2 and 3. But we can't get the exact value without logarithms. And so here's how it works. So on your calculator, you have 2 log buttons. If you if you have a calculator on you, I locate those. You got the LOG button and the LN button. So one works in base 10, one works in base E. And so you get to decide which one you want to work with. So say I want to work with the natural log. Well, then I could take the natural log of both sides and write natural log of 2 to the power of x is equal to the natural log of 5. Okay, we still need to get x by itself. But now by doing this, we know some rules of logarithms. So we would like this x by itself. So we'd like to move it over here. And there's that power property that allows us to do that. So now we could write x times the natural log of 2 is equal to the natural log of 5. And then to solve for x, we divide both sides by the natural log of 2. And so we end up with x is equal to the natural log of 5 divided by the natural log of 2. And this is where your calculator comes in. So you could type in natural log of 5 divided by the natural log of 2. And you get 2.32. We're going to round this to the thousandths place. So go out 3 decimal places, so 2.322. Okay. So normally, if I asked you to change this into log form, what would we get? Log base 2 of 5 is equal to x. And I'm going to put the x on this side, okay? And so we have this x is equal to log base 2 of 5. But then we have this log x is equal to natural log of 5 over natural log of 2. And I want to do one more thing, and then I'm going to make a comparison here. So say instead of using natural log, we use the other button that we have on our calculator, log base 10. And I went through this process, and I'd say, well, log of 2 to the power of x is equal to log of 5. And then use the power property and said, well, x times the log of 2 is equal to the log of 5. And then divided, I end up with x is equal to the log 5 over the log of 2. Do we get the same exact answer? If we use log instead of natural log? Try it out. Get the same exact answer. But when we use base E, the other uses base 10. We get 2.322 again. So we have 3 different expressions for x, and so we could either write, so log base 2 of 5 is the same thing as the natural log of 5 over the natural log of 2. It's also the same thing as the common log of 5 over the common log of 2. And in general, we can use any base we want. So here we're using base e, or you're using base 10. But if you want to use another base, as long as the bases match, you could say that this is equal to log base 22 of 5 over log base 22 of 2. Okay. Does that mean that the natural log of 5 is the same value as the log base 10 of 5? No. It just means the ratios are always going to be the same. Okay. Actually, the individual values are very different, but the ratios will always be the same. And so we usually, instead of doing all this work up here, we usually just skip to this part. So if I have log base 2 of 5, I just jump straight to the fraction. We call this the change of base theorem. But I wanted to show you where it came from. It just came from a little bit of work using the power property. So it's not just magic that came out of nowhere. Okay, there's a process here. So we're going to be using this change of base formula here. We see it right here. It says the change of base theorem. So they're saying, well, if we have log base c of a, we can change that to log base 10 of a over log base 10 of c. But it doesn't have to be that. It could be the natural log of a over the natural log of c, or any other base that we want to use. And so in general, that's what they're saying over here. B could be any base you want, as long as your base is greater than 0 and not equal to 1. Okay. At the top of our notes, we just have a piece to recall, because we're going to be changing things from exponential form to logarithmic form. And we've been doing that. We did that on homework last night. We've been doing that a lot. But we're going to need that again. Okay, so let's take a look at some examples. So we're to solve for x. Goal again is to solve for exponents that we normally would never be able to solve for using a calculator. Write your answer in terms of logarithms in 2 different ways. So we get to pick 2 different bases, and so we're gonna use one with the natural log and the other one with the log base 10. Then evaluate your answer using a scientific calculator and round your answer to the thousandths place. So we're going to go 3 decimals down. Okay. So here's what I want your work to look like. So first thing, just rewrite this as a log. So out of exponential form into log form. So this would be log with what base? With the base 7. And the 30 goes here. Okay. And usually we put equals x, but let's put the x on the other side. Okay, because we're solving for x. And then the change of base formula says, well, we can, right now it's base 7, we can change it to any other base we'd like. So we could rewrite this as a base 10. So I could write log, I could write my 10 if I want, I don't have to. But then I'm going to grab the 30 on top. So log base 10 of 30 over log base 10 of 7. Okay, so that's something we can enter into our calculator because it works. But it wants us to write, it says write your answer in terms of logs in 2 different ways. So that's one way. The other way, just write another fraction with a different base. So we'll use the natural log, which is, remember, is base e of 30. Or a natural log base e of 7. Okay. And you could type either of these fractions into your calculator to get your decimal value. You pick which one you want to plug in, and we're going to approximate it 3 decimals out. you should get 1.748. Okay. And remember what we're answering. We're answering 7 to what power equals 30? Well, about 1.748. Okay. Question on that problem. Okay, so let's look at the next one. We got 8 to the 2x is equal to 74. And so first step, change it out of exponential form into log form. And we're going to get 2x, the exponent, is equal to log base 8 to 74. And I'm going to rewrite this as 2x is equal to, and we get to change our base. So I'm going to use natural log first. So natural log of 74 over the natural log of 8. And they want us to solve for x, so we need to get rid of this 2. I have a fraction already. So you get rid of the 2 by dividing by 2 or by what? Multiplying by a half. And I'm going to choose the second one, multiply by a half, because I have a fraction, and thinking about dividing a fraction by 2, you end up with a couple fractions there. So I'm just going to multiply both sides by a half. And then I end up with x is equal to the natural log of 74 divided by the natural log, 2 times the natural log of 8. Okay, and you can leave it like that, or you can use your rules of exponents and make this 2 a power of 8 and make it natural log of 64. You have some freedom there, but we solved for x, and so that's one answer right there. Now it would like us to rewrite x in 2 answers, so all we have to do for our next one is rewrite the same thing but just use a different log, so with a different base. So I'm going to use, this is also the same thing as log of 74 over 2 times the log of 8. And this is just, we're having you do this just to remind you that it doesn't matter what base we're using. Okay. So then be careful when you type this into your calculator. Use parentheses around that denominator, the whole denominator, when you type it in. The test that you have next week has 2 parts. It has a no calculator part, and then it has a calculator part. And the calculator part, so you want to know how to use the calculator. You want to know how to type this in. So let's practice doing that. You could make that natural log of 64, yeah. Might be a little easier to type in that way. So you guys getting 1.035? .035. So if you're not getting that, it might have, again, you need that as parentheses around the whole denominator when you're typing that in. Okay? Yeah. Yeah? You can. No. No. You just need parentheses when there's more than one thing. Okay? So if you hit enter first, so I do natural log of 74 divided by natural log of 8, hit enter, and then hit divide by 2. That would work. Okay. All right, on to the next one. So before you change it into log form, make sure you don't have something like this 5 out in front. So we want to get rid of that 5 first. So we just want the base and the exponent equal to something. So let's divide both sides by 5. And what is 400 divided by 5? 80. Okay. And then we want to change it out of exponential form into log form. Okay. So we're going to write log base what? 2 of 80 is equal to 5x. Okay. And so then I'm going to change it out of this log base 2 and get 5 times x is going to be natural log of 80 over natural log of 2. Careful, you cannot divide the 80 by the 2. Okay? Might be tempted to reduce that and say, oh, that's just natural log of 40. That's not true. Okay? So we do want to solve for x, though. We want to get the x by itself. And so multiply both sides by 1/5. And you end up with x is equal to the natural log of 80 over 5 times the natural log of 2. And again, you can make that 5 the power of 2 if you'd like. Also, here's another route for those of you that are comfortable with this kind of thing. You could change this to 2 to the 5th to the power of x equals 80. And then when you change it, you get x equals log base. The base is 2 to the 5th of 80. You can get natural log of 80 over natural log of 2 to the 5th. And then you've already solved for x that way. There's lots of ways to do this, okay? And you can get the 2 to the 5th our way as well. So key thing is that we're doing it correctly. We're getting the right answer, okay? So we're asked again to write this in 2 different ways. We got one expression here, and I'm just going to rewrite it in terms of log base 10. Log of 2, and then approximate it. You should get about 1.264. So try the next one. 7 to the x plus 2 equals 32. See if you can get an approximate value for x. So first step is to change it out of exponential form to log form, and we get x plus 2. Our exponent is equal to the log. The log has a base 7, and 32 is what we plug into that log. Okay. I'm going to change the base. So we get x plus 2 is, I'll use natural log 32 over natural log of 7. And I'm changing the base because our calculator does not work in base 7, but it does have the natural log button. So I'm using something that our calculator would be able to use. And then I need x by itself, so I'm going to subtract 2 from both sides. And I get x is the natural log of 32 divided by the natural log of 7. minus 2. And so there is an expression that I can type into my calculator to get an answer. It asks for two different expressions, so the other one would be maybe the log base 10. Okay, both of those work. And so let's approximate that. So you should get negative 0.219. Okay, well, look at what's happening here. Okay, if we go back to your original problem, okay, the original problem is 7 to x plus 2 equals 32. Now, if I just asked you, well, 7 to what power equals 32, you'd say it has to be between what and what? Well, 7 to the first power is 7, too small. 7 to the second power is 49, too big. So it's going to be x, or our exponent has to be between 1 and 2. Well, what if I'm saying it's x plus 2? Well, I'm going to have to make x negative to bring it down, because I already have that plus 2. I have to make it between 1 and 2. And so now if I have the negative 0.0219 and I add 2 to that, I'm going to get a number between 1 and 2, and that's going to be the number we need. Okay, so that's what's happening. All right. This next part, solve for x, write your answer in terms of a logarithm. So we don't need 2 now, just 1. Then evaluate your answer using a scientific calculator and round your answer to the thousands place. Now what's different about these two is look at the base of the exponents. Base 10, base e, and that's exactly what your calculator works in. And so when I use a log on this, if I have a 10, I'm going to use the log, because that's base 10. I'm going to match the base to what's there, and something different happens on these. So first we need to subtract 2 from both sides on this problem. We get 10 to the power of 4x is equal to 15. Just checking. 13. I can. Thank you, Colton one. Okay. So when we change this to exponential form, we got 4x is equal to log base 10 of 13, right? So I don't need to change this into any other log form now, because our calculator works in base 10. And so when I divide by 4, I just get x equals log 13 divided by 4, and just type that into the calculator. So we don't need to change a base formula when we're working with the base that our calculator already uses. You can use a change of base formula, but you don't need to. Okay? We're approximating to the thousands place. And you should get approximately 0.278. Okay. So it's a little less work if you're working with a base that your calculator already has. So on the next one, what would you do first? You got to divide by 3 first. You get e to the power of x minus 4 is equal to 7. Change it to exponential form, and you get x minus 4 is equal to what? Log base e of 7, which is the natural log of 7. And so x is going to be the natural log of 7 plus 4. And you type that in your calculator, you got an answer. So rounded to the nearest thousandths place, or rounded to the thousandths place, we get 5.946. The next part, we want to solve for y, so we're not getting an, we're just rewriting the equation, and we're going to rewrite it in terms of x, so we're not getting a decimal value. Actually, there's no calculator needed for these problems here. So if you want to get y by itself, we're going to subtract 7 from each side, so you get 10 cubed, or 10 to the 3y minus 1 is equal to x cubed minus 7. Change it to log form and you get 3y minus 1 is equal to log base 10. We don't have to write the base 10 of x cubed minus 7. Now we're taking the log of that whole piece, so it's important that you put that whole piece in parentheses. And then we want y by itself, so we add 1 and divide by 3. So I'm going to add 1 first. And then divide by 3. And that's what your answer looks like. Okay, so we're just using logs to solve for for a variable in the exponent to get an expression in terms of x. Okay. So the last one, the last one is in log form, not in exponential form. We want to get y by itself. First step, subtract 6, get that natural log by itself. And then what would you do to get y by itself? Distribute what? ln's not a number to distribute. So log. So we want to get rid of, we want to get the 2y plus 5 out of that ln. So we want to get rid of the natural log. So it's a technique that we haven't used today, but we used yesterday and the day before. So it's an older technique. How do you get something out of log form? Put it in exponential form. So what would it be? What would exponential form here be, guys? What's the base? E. What's the power? X to the 4th minus 6 is the power, because the log is always equal to the power. And then set that equal to 2y plus 5. So now the 2y, the y's, we're able to solve for y now. We're not, got rid of that natural log. Subtract 5. And then divide by 2. So e to the power of x to the 4th minus 6 minus 5 all over 2 is equal to y. Okay. All right, so homework is all the problems from 9.7.